Welcome back to limits in Calculus 1. In this video, we're going to go over a technique for solving some limits, and this is limits by factoring or limits by factorization. This is especially useful whenever you have something, and it really doesn't matter if it's in the numerator or denominator, and sometimes it does matter, but whenever I have something in the form of usually something squared minus a number. Okay, it could even be in the form sometimes of something minus something squared. Usually this is most useful, and I say usually because there are exceptions, but when you have a subtraction sign here, that's usually when this is the most useful. Okay, but a lot of times things we're going to deal with are in the form some variable, usually x is what we're dealing with, squared minus some number. All right. Now, one thing I can just go ahead and tell you just from experience is that when I have something like x squared minus 1, this is just x minus 1 quantity times the quantity x plus 1. Well, there's sort of a way that I figure out how to do this. All right, let me show you how to do this. If I recognize that at least one thing here, particularly usually it's the x squared, that if I have this x and it's squared, and it's subtracted, you're subtracting something else from it, what I'm going to do is I'm just going to take the square root of both of these numbers or variables. So let me take the square root of x squared. What's the square root of x squared? Well, that's just x, right? Now let's take the square root of 1. Well, the square root of 1 is just 1, right? So that means whenever I write this, when I want to basically expand this out into two separate products, I'm going to take x and add 1, and then I'm also going to multiply that by x, and then there's going to be a minus 1. So I'm going to have x plus 1, that's this right there, and then I should also have an x minus 1. So here's the minus 1, x minus 1. Okay? Remember, what I did is I took the x squared, took the square root, and that's x. I have the 1, I take the square root of that, and that's just 1, so I should have x. Let me do this in purple. This should be x plus 1, this, times x minus 1. That's from this. All right? Let's do another example just to get the hang of this. Suppose I have x squared minus 9. Well, if I want to figure out what this is, I'm going to take the square root of x squared. Again, we know that's just x. Okay? That's x. And then I take the square root of 9. Square root of 9 is 3. And then what I should ultimately have is I should take x, and then I'm going to add 3 to that. And then I'm going to take x and subtract 3 from that, and that's going to be what x squared minus 9 is equal to. So what's x plus 3? Well, I just have this x plus 3 right there in parentheses. And then I'm going to take x minus 3, and that's going to be this right here, x minus 3. And the product of these, x minus 3 times x plus 3, is x squared minus 9. All right? And again, we'll find that the most important form of this, where this is most applicable, is just when you have x squared minus n. And the key here, and I've sort of indicated it here, is you have to have this subtraction sign. Otherwise, it can be, you're not going to be able to solve this normally. You'll have to do something else that's a lot more complicated, which is normally not something you're going to see. All right? All right, so here's the thing we have. Suppose I have this, and I've already basically broke this up. This would have been x squared minus 9. I've broken it up into x minus 3 times x plus 3, and suppose I have an x minus 3 in the denominator. Now, suppose I want to evaluate this at x equals 4. All right, let's just evaluate it. What is 4 minus 3? Well, that's just 1. Now we have x is 4, 4 plus 3. 4 plus 3 is 7. And then what's x is 4 minus 3? What's 4 minus 3? That's just 1. And actually, I get a nice number. Notice when I plug that in, I'm not dividing by 0. I'm dividing by something that's not 0. And so that's just something where I can just plug things in, right? And sometimes you can just plug things in, all right? It's worth checking. However, now let's do the same thing, but try to evaluate this at x equals 3. Okay, so let's look at this first one. What's x is 3 minus 3? 3 minus 3 is 0. Here we have x. What's 3 plus 3? Well, that's 6. And then we have this x minus 3 in the denominator. What's 3 minus 3? That's 0. Notice something really bad has happened. I have a 0 over 0. And this means I can't just plug the numbers in. I can't do that. It's not mathematically allowed. In fact, what we'll find is, even though I have a 0 here in the numerator, this actually ends up being a nice number. Okay? Now, I don't know what this number is yet, but ultimately this is not going to be 0, and we're not going to be dividing by 0, which means I'm going to have to do a limit by factorization or factoring. Okay? And a good key to this, a key of when you would want to use this, is when you have something in the form of, notice I have like an a squared minus b, okay, something like that, where I can, something in this form, right? I think I used the word n, the letter n here. Let me do that. I used n. So a squared minus n, okay? And if you have something like that, so x squared minus 9, x squared minus 16, even 16 minus x squared. As long as you have that subtraction thing, and one of these things, at least one of them is squared, usually the variable, you can do this. So what I'm going to do is show you how to break this up into something that's a lot easier to deal with. All right, so here I have limit as x goes to 3 of x squared minus 9 divided by x minus 3. Now you can check, right? I can plug this 3 in here and I get 3 minus 3 in the denominator, and that's 0. Okay, so I'd be dividing by 0 there, which is an indication I can't do that method of just plugging in. So I have to manipulate this. Remember what I showed you? If I have x squared minus 9, what do? Well, I'm going to take the square root of both of these numbers or variables. So I'm going to take the square root of x squared and the square root of 9. What's the square root of x squared? That's just x. What's the square root of 9? That's 3. So remember what I said, you're going to have an x plus 3 and an x minus 3. So I can take this x squared minus 9 and substitute it for x plus 3, and then I can have x minus 3. And then the whole thing, notice, is divided by x minus 3. All right, so now notice I have an x minus 3 in the numerator and x minus 3 in the denominator. These cancel, okay, and that's good because I've gotten this out of the denominator. So now I have the limit as x goes to 3 of x plus 3. Now, is there any way here I'm dividing by 0? No, because notice I can take this 3 right there and plug it in, and if I take 3 plus 3, that's just equal to 6. And because I'm not dividing by 0, I can just substitute this 3 in for x now. I couldn't do it here, but I can just substitute it in here and get 3 plus 3, and this is equal to 6. So it turns out this limit is equal to 6, even though when we first substituted in, we got 0 over 0. But this limit, it turns out, is equal to 6. And most of the time when you have some situation like this, the limit actually is not 0 over 0. It actually is some nice number like 6. Okay? Let's do some actual examples now, some more examples. All right, so here, let's see. So I have x squared minus 16 divided by x minus 4. All right, so I'm going to rewrite limit as x goes to 4. Make sure not to forget that. Anytime you're doing a limit, if you do some manipulation to it, you have to continue to write this limit notation. All right, so so I have this squared minus a number, all right? So remember what I do? I take the square root of this variable and the square root of this number, and I get that's x and 4. So that means, and you can go back over here to see what I did, remember. Take the square root of x squared, I got x, the square root of this number. In this case it was 1, I got 1, so it's going to be x plus 1 times x minus 1. Here though, it's going to be x. What's the square root of 16? It's 4. So I'm going to have an x plus 4 and an x minus 4. Okay? That's what this numerator is equal to, and then the whole thing is divided by x minus 4. All right? And this is nice because, notice the x minus 4 and this x minus 4 cancel. They're the same in the numerator and denominator. So that means this limit as x goes to 4 is just simply equal to x plus 4. And now, notice, I can just substitute this 4 in, and I get 4 plus 4. And what is that equal to? That is equal to 8. All right? So hopefully that makes sense. All right, let's do another example. So here's another one that's very similar. All right, so let me go ahead and write the limit notation. So I have the limit as x goes to 1 of x squared minus 1 divided by x minus 1. All right, so remember if I want to have, I have something of a variable squared minus a number, what I can do is I can just say, okay, I'm going to take the square root of x squared, and that's just x, right? And what's the square root of 1? It's just 1. So the square root of this, remember, is x. The square root of this is just 1. So I should get an x plus 1 times an x minus 1. That's, if you multiply these two things, that's x squared minus 1. And then the whole thing is divided by x minus 1. Now notice, again, I have an x minus 1 in the numerator and an x minus 1 in the denominator. These things are going to cancel. And so now I get this is the limit as x goes to 1 of x plus 1. And again, notice I can actually now just plug the 1 in there, and I get 1 plus 1, and this is actually equal to just 2. Notice if I just plugged 1 in here initially, I'd get divided by 1 minus 1, and that's dividing by 0, and I can't do that. That's why I have to do this manipulation and cancel the x minus 1s. One thing you're going to find in problems like this where you recognize that you have to factor is that pretty much in general, they boil down to the same thing every single time. Okay, these problems are not, they don't vary a whole lot. Some of them are more complicated, like this challenge problem we're about to do. But in general, you basically apply the same techniques every single time. Okay? So let's worry about this one now. All right, so for this one, instead of having an x squared minus 1 in the numerator, it's now an x to the 4th minus 1. So now I have the limit as x goes to 1 of x to the 4th minus 1 divided by quantity x minus 1. All right. I'm going to do the same thing here that I did before. What is, and I'm going to try to squeeze this down here a little bit. All right. What is the square root of x to the 4th? All right. Because I'm going to take the square root of this, and then I'm going to take the square root of this too. Just like I did before. What's the square root of x to the 4th? That's x squared, right? And then what's the square root of 1? That's just 1. So actually, when I write out this limit, remember I have this x squared, and then I'm going to add 1, and this x squared, and then subtract 1. It's the same thing from before. I'm going to have x squared plus 1 times x squared minus 1 divided by x minus 1. All right. So sometimes you can have not a squared here. If I had an x to the 8th, then the square root of x to the 8th is actually x to the 4th. Okay. But I wouldn't suggest that you'd see a lot of that on exams. All right, so I have this limit here, and I have this term right here, notice. This is actually right here, x squared plus 1. Now notice, I do have something squared, the x, that is, and I have a plus 1, but it's plus 1. So can I really do anything from this based on what we've talked about? No, that term I really can't do anything with. However, this term, I have an x squared minus 1. Do we know how to deal with that? And the answer is yes, we do know how to deal with this thing, and we're actually going to just do it again. We're going to do the same thing we just did and do it a second time. So what is the square root of x squared? That's just x, right? What is the square root of 1? That's just 1. So one of my terms when I substitute here should be an x plus 1. The other one should be an x minus 1. So let's rewrite the limit here. So this is the limit as x goes to 1. I'm going to keep this x squared minus 1 here, or excuse me, x squared plus 1, because I can't do anything with that. But I can do something with this term I circled in green, x squared minus 1. This is equal to, notice down here in green, it's x plus 1 times x minus 1. And that's essentially what this x squared minus 1 is. It's just this right there. All right? Then the whole thing is still divided by quantity x minus 1. Now this is actually a really good thing. Notice, I have an x minus 1 in the denominator, and if I just plug 1 in, I'm dividing by 0. But I also have an x minus 1 in the numerator, so these things cancel. Okay? And so what I'm left with is the limit as x goes to 1 of x squared plus 1 times x plus 1. Now notice here there's no way I can actually be dividing by 0, okay? So if you could potentially FOIL this out, or you could just start plugging numbers in. I'm just going to plug numbers in. So I'm going to plug a 1 in for this x squared and a 1 in for this x. So what do I get? I'm going to get 1 squared, that's this x squared, 1 squared plus 1 times the quantity. I'm going to plug 1 in for this x, 1 plus 1. So what is this equal to? 1 squared is 1. Plus 1 is 2, so this is going to be 2. And then I have 1 plus 1 is 2, so times 2. So this limit is equal to 4. Okay? So sometimes when you have something that's it's not like x squared, it's x to the 4th, you may have to apply this technique a second time. Usually that's not the majority of the problems on the exam. The majority of the problems on the exam that you'll see are similar to these first two up here, where you're going to have something squared, like an x squared minus a number like 16 divided by something else, and pretty much on the exam something is going to cancel, like this x minus 4 in this topic one right here. Now, there are some limits you can find where they don't work out very nicely. In general, you won't see those on the exam because they're not solvable by these methods. They're teaching you these methods just because a lot of problems boil down to this. But everything on the exam should work through a technique that you've seen here, okay, if it's one of these types of problems, okay? In the next video, we're going to go over another technique, which is limits by conjugates. Okay, we're going to learn about what a conjugate is and how we go about multiplying by conjugates and solving limits that way. All right, so I hope this video helped you. Make sure to like the video and subscribe to the channel for future videos and notifications. Thank you very much.